Okay, so we're going to talk about methods. And methods actually begins on page 118 in chapter 4. So it's not the beginning of the chapter. The beginning of the chapter is arrays. And like I said, we really won't be working with arrays for a few more weeks, several weeks actually. So feel free to skip that. I know it's hard to skip a section in a book. You just feel like you're missing things. But with this book, they really have it set that way. So methods, what are methods? Well, methods are modules or subroutines or procedures or whatever you want to call those little sub-programs that we have to create in any kind of programming language. So I like it because basically a method is a logical chunk of code that's defined and can be executed. We use methods to separate functional tasks in our program. We also use methods to eliminate redundant code. And methods help us to implement modular, maintainable programs. Now, a few years ago, when I taught programming and there were functions and subroutines, people would get very, very confused. Should I use a function? Should I use a subroutine? What are the rules? Tell me. So it's nice that they're all just methods now. So you don't have to worry about calling it a specific thing. It's just a method, and a method is a subprogram. So here's a beautiful hierarchy chart. If you remember this chart from your 120 class, it's a super easy chart. I've got a main method, and my main method is going to call an input method, it's going to call a process method, and it's going to call an output method. So it's all nicely organized. And our hierarchy chart just shows us that. What calls what? Because as things get really, really complicated, it can be a lot more involved than that. So it can be really important to have that hierarchy chart. And it's really, 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 how many times can I say it, important to eliminate duplicate code. So if I see duplicate code somewhere, 2 lines of code in my program that are the same as these 2 lines, I'm going to look at those and I'm going to think, should I have a method for those 2 lines of code? I should if I can, right? Because anytime I can separate code and isolate it in its own method, I've made it easier to maintain my program, easier to test my program, easier to do everything. So less code matters. I want fewer. I have a terrible robot story. There's a school in the state of Missouri that has a robot, and they kind of have a dynasty that they always win the robot contests in Skills USA. And I had a friend who was bound and determined to make them not win the robot contest at Skills USA. And so he sent his coders and his robot people. And when it all was all said and done, the other team still won because unfortunately they knew what the program was supposed to do. But they did it in like 500 and some lines of code. And the guys that we sent did it in like 38 lines of code. They felt like winners. They didn't care who the judges picked because they were like, we did it better. It doesn't matter what they said. So less code matters because we can be more efficient if we can do things that way. I don't want to have that same code repeated 700 times. What if I have to change it? I have to change it in 700 places. Okay, so a method. These are things that you can think about when you think about a method. A method is like the chorus to a song, right? It's a recipe you use over and over, or it's like doing the laundry. It's something that could be repeated, something that's done the same way each time, and something that might result in something to eat or not. Maybe, I don't know. Depends on if you were doing a recipe method. I like the chorus to a song one because we all know, you know, they get out in that verse and then they get back to the chorus and we're all used to it. So a C# method really has 3 things. It has the method header, has the method body, and the method closing. And that's it. Now in our method header though, things can be a little bit confusing. So we want to try to really understand what we have going on here. The first thing, the word public, is my access level. And you'll see that we'll be leaving that off here at the beginning a lot, just to simplify things. If we leave it off, our access level defaults to private. And that's okay, because the programs that we're writing, we can keep it private. The next thing we have is a special modifier, that word static. And we'll be learning a lot about what that means and what it does. The third word is the first required thing. So in our textbook, we might see method definitions or method headers that start there. And that word void means this method doesn't have any output. No data is returned from this method. Next, my method is the name of the method header. And within the parentheses is a list of all the parameters or inputs that our method needs. So static is a modifier, void is the return type, my method is the method name, and then our parameter list is within parentheses. In our parameter list, if you notice, we specify the data type and a variable name, just like we were declaring a variable, because this basically declares that variable for within my method. In C#, we make method names start with the uppercase letter. So just like the right line has specific syntax, our method does also. And we can use any statements like that inside our method body. So here I've got my method header that ends with an opening curly brace. Then we have all of our method body, and then our closing curly brace is the end of our method. So just like our main method, we have to have our curly braces. Okay, so let's write this program. Can you guys write it? It's quick. Open Visual Studio, create a new project, and you can name it. This one is going to be Chapter 4. So I would just do Chapter 4 test. It only has these few lines of code. Yes.
Does this PowerPoint exist in Canvas?
No. So I'll send it to you in Discord. Remind me, will you?
Okay.
Because I did not the morning class. I'll have to send it to him. I finished it last night. I couldn't decide where to put it. Organization skills. Did it take it? Can't see it, can you? Sorry. I'm messing with you. So in your program, you have your main. Your main method calls my method. Is everything working? Make sure it's working so you can have it as an example. You should just see that 7.5 coming out. See where I was going with that. I have a feeling that's our old book, and I need to create a sample for you. Okay, if everybody's got it on this one, then we created our method, my method, and we said our my method requires one input, and it's a double. And we want to call that my variable within our method. And all our method does is the right line statement to output the variable is and our variable value. So when we call our method and we pass a value 7.5, that's what should be printed out. The variable is 7.5. So you could change this value up here if you wanted to and run it again and see how it changes that value. So that's a nice method. It doesn't do a whole lot of things, just outputs whatever it was passed. Okay, so what if we want to return a value? That method was fine. It just took that data that we passed it and did something with it. But what if we want to actually do something and then return that to our caller? Well, our method header is going to change just a little bit, not a whole lot. We're still going to have the public access level statement and then our static modifier. But here, instead of the word void, we have the word int to say that now our my method is going to return data of type integer. Our method name is still the same, and the parameter list is still the same, just one double named my variable. Let's look at how that would change our code. Whenever we have a method that returns a value, somewhere in the method body, there has to be a return statement. And that return statement has to specify something to return that is an int. So they have to match. So when we return a value, we use that return keyword and specify the data that we want to return. And it could be just something hard-coded in there, a literal like the number 5. It could be a variable, but we can only return one thing. So here is a method that returns a value. In this example, we've changed things up a little bit. Our my method now says it returns an int instead of being void. You could go ahead and add this to your code as a completely separate method. Don't change the my method you already have. Just add this one. And notice how they won't conflict with each other. And I'll tell you why. Because here we're saying we're going to return an integer. So we're going to read in that input variable and print it out. And then we're going to return our variable multiplied by 2, but we're going to cast it as an integer to make sure it's an integer. And that is a casting when we have a data type within parentheses. Now I want you to put that second my method in there, just so you can see that it won't conflict, even though it's got the same name. sometimes I feel bad for you guys that you've had to have old people as computer teachers your whole life when you know more about it than they do. But I swear to God, it's not going to care this time, really. Different.
The PowerPoint you put in this for this data type.
Oh, darn it. See, here I am doing old people stuff. I'll fix it then. No wonder it didn't care. Now you tell me if it cares, because it could. I could be lying. Now, when I have a method that returns a value, I need to figure out what I'm going to do with that return value. So in this example, we declared a variable to hold an integer, and then we use that variable on the left of the equal sign before we call our method. So any variable to the left of the equal sign when we call a method is going to receive the returned value from that method. So our multiplication of taking our variable times 2, that 15 is going to be returned to the return value variable. Now I'm going to keep going though, because I don't want you to test yours yet. Now what if I need more than one parameter? So far I've just shown one. Well, here in this example, our my method now wants a double, but it also wants an integer data type as input. So we can do that just by specifying a comma and then another data type variable name. So all of our parameters are going to be data type variable name, as many as we want. So if we stuck this method header in there, we don't have much method body, so our program would get a little upset, but we could. So let me review all of these. So how can I have my method in my program multiple times? Because it's object-oriented. And in an object-oriented program, I can have the same method as long as the method's signature is different. Well, what's the method signature? The method signature is the return type, the name of the method, and all of the method parameters. And all of that data together is used to build the signature, or almost like the keyhole for this method. Then when I call this method, C# is going to say, which key are they using? Are they using the key that expects an integer and passes in a double and an integer? If so, I'm going to use this method. If they're using a call that passes in a string, I'm going to use this method. This is overloaded methods. So with C#, I can have the same method, the same name, multiple times, as long as my signature is different. It's a different method. Where I might want to do that is like drive, right? So I could have a method called drive that if I'm working with an automatic, I just push the gas, right? I could have a method drive that if I'm working with a standard, I have to shift into first, use the clutch and the gas to drive. I could have a method called drive that was for an 18-wheeler that said, I don't know, I have to do 2 clutches and all sorts of things before I can drive. They would all be drive, but they would have different signatures, right? Different requirements. So I can do that with C#. And it's going to be something that's going to give us a lot of power. So methods. C# implements all of our functions and subroutines as methods, any subprogram. And each method has a unique signature that's developed from its header. And that header is return type, method name, and parameters. A method header specifies the input required through parameters. And a method header specifies the data type of the return by the return type. Our method has a body of code, and our method body is enclosed by braces. So you should be able to save that one program and not do too much with it. Okay, just real quick, before we go, there is a link on Discord to, well, I lied, hang on. There will be a link on Discord. I didn't get it for our class. Oh, here it is. Okay, to Quizlet. Go ahead and click on that, and it'll take you to this really, really large vocab terms deck, 109 terms in this deck. Quizlet, if you haven't used it before, is a great vocab website, and if you can get a handle on the vocabulary, you have so much going for you already. I'm gonna set the alarm for about 10 minutes, maybe 7, and give you some time to go through these terms, and then we're gonna play a quick Quizlet game before we head out. No, you should have done it already. It's mean to you.
Oh.
And you got two now. Lots and lots of terms. Okay, here we go. Now this game that we're gonna play, Quizlet Live, is best if you have a phone. If you have your phone and you have data, that would be best. If you have your phone and you can use the Wi-Fi, that would be second best. If you can't use data on your phone and you have a laptop, that would be good. In the worst case, use your desktop computer and your team will run back and forth to you. But we'll try. If we can get it, all of us on mobile devices, we're better off. Okay, so you want to go to www.quizlet.live and enter this code. It's awesome. Okay, this is methods. Oh, you're good, good. We should have 20. Oh, so close. Two more, two more. One more. Come on, before we start dancing. Oh, yeah. Okay, here we go. Okay, go find your team. Where's those bears? He's tethered to the computer. Don Bison. Everybody got their people? Okay, here we go. Now, you're not going to see the same answers on each device. You're going to have to put all your devices side by side to see all the answers. So cooperate. Oh, somebody did. Blake. Where's Blake? Can you reconnect? It's dropped you. Do it. Oh, you were on a computer. You're going to have to stay at your computer that you were on. Yeah, Jackie will run back and forth. She's okay. She'll get it. So stay on that one, otherwise it'll get all confused. Hang on just a sec. One small difficulty. They're going to beat you guys because they have to run. Usually the teams that have to work together the hardest do the best. Hang on. Just a sec. He was trying to be tricky, and it's like, no, I'm not going to let you. Is it going to let you? Oh. It messed up. Nah, it won't work. Guess what? Got to start over. Yeah, because it would have showed you guys, his answers would not have shown anywhere, and you guys would not have been able to pick them. Go find your new teams. It's too late. I've played it a bunch. Go find new teams. It won't work when someone does that. Where he was disconnected. His answers would not show up anywhere, so you guys would not have been able to pick answers that were showing up on his screen.
My boyfriend's here at my wallet. Should I wait after the game to go get it?
Oh, tell me about 10 minutes.
Okay.
And then we'll be done. Yeah. We'll get out of here. Not a problem.
It still says waiting for the next round.
Oh, tell it. Do it, dumb thing. Okay, as long as you're not in it, we're okay. Because it doesn't have you anywhere.
I'm on reindeer.
You're on reindeer. So what? Can you click on anything? Does it give you
can-
anything? Okay, we're gonna try, but reindeer might be messed up. Let's see if he can get it. It gets so weird when somebody gets messed up. It's just a pain. Okay, we'll try. Add. Look at it. Ugh. One more time. Okay, go find your team. See, this makes you get to know everybody, right? Yeah, those were good. Find your team. Hurry. We just wanted him to be able to play. We don't want to leave anybody out. Are we ready? Okay, they're getting there. Jackie's got it. Here we go. Everybody ready? I'm doing it this time. If anybody gets dropped, it's just too bad. Okay. Start game anyways.
He's still not in, by the way.
No, I know. It won't let him.
I suppose I'll just hang out with you up here for the first
Sure, you could watch them.
Yeah.
See what it's doing. I don't know if it'll ever let you play.
Yeah, sorry. I just
No,
broke
that's
down.
okay. It just gets so weird.
That's about how it goes in games.
Just the way, huh? That's all right. You know, those programmers that never run into problems, they never know how anything works.
Well, I still don't know how anything
Yeah,
works.
no, you don't say that.
I'll figure it out eventually.
You say, well, I run into problems, so I always know
Yeah,
how
that's-
everything works.
Sure, of course.
That's
yeah.
right. I always kid with everybody about because I taught networking for lots of years, and so I had a student who making networking cables, putting an
Oh,
end
guys,
on.
doing them themselves, gotcha.
I had one guy who he ended up working for the school district, but he just had these like really short fingers. It was to the point where no one in the class wanted to try anymore because we were all so tired. Like, we tried,
tired of
and
waiting,
it's just like,
yeah.
yeah, this is not your thing. And like,
We miss one keyboard in our
do I?
Sorry?
We miss one keyboard.
Yep, that would be me. Sorry.
That's why I kept redoing it. See what happens if
Sorry.
someone's missing?
Okay, I'll go check keyboards.
Whoa, they were super fast. I'm clicking exit game, and then I'm going all the way back in so it will let Blake in and not leave his answers out there hanging in the middle of no man's land. Okay, everybody's got to join all over again. Yeah, it's so worth it. One more, one more. Ah. Okay, find your team. Who's don't shuffle the team? I like the little stew. This will be you guys' favorite game now, I can tell.
Where's Carmelian?
Are you set? Ready? Ready? They're moving. Here we go. Oh, good job. You guys get away from that team that's trying to listen in. Okay, we're ready. Some hard ones. Guess I know who the foxes are. Oh, good job. I thought that they were going to get beat. All right, get out of here, you guys, and I will see you Wednesday. Do reading, but ignore those parts we're ignoring. Have a great day. Thanks. Sure. I think I got the right presentation.
So, and how we do this? The time, like, how do we do that?
Save it. Let's see.
Not easy to do it.
Well, I think it is. It's just something I wasn't familiar with, you know? I just didn't even know you could do it. But I need to be familiar with it.
You particularly busy at the moment?
Do what?
Are you particularly busy at the moment?
What you need?
I just had a quick question about why I shouldn't be using go-to statements in there. I just wanted to know
Oh.
specific reasoning.
Oh, because go-to is alters the flow of control, and any statement that alters the flow of control is considered hard to maintain.
Okay.
Because when you're working with something on down the road and all sorts of stuff is thrown around it, and then a developer who is analyzing that code might not realize that there's that flow control statement in there, and so they're just discouraged in programming. Yeah, and so there's nothing wrong with doing it. I was like, oh, I don't know what to say. Because like a couple semesters ago, a guy in the C#2 class was doing his big presentation to the class at the end of the semester, just about C#. And his whole presentation was how he had solved this problem at O'Reilly's by using a go-to. And I was like, oh no. And so I was having this major meltdown and I didn't know what to do. And he kept saying, well, my boss at O'Reilly's was super impressed. And then I was like, no. Yeah, and it's just because I've had to maintain code like that in the past.
Gotcha.
And as it grows and evolves, it just gets
becomes
really hard to handle. So
Thank
you for not stressing.
I was just curious if it was like something with the verification that I'd used.
No. You did everything fine. We just don't like those
Hard to
alter
follow.
flow of control statements.
Okay, thank you very
Yeah,
much.
no problem. Thank you.
Have a good rest of your day.
Well, where in the world? See, I should have just said, I need that. Oh, you know what? I do have it.